Hey there guys, here we are going through Edexcel's June 2018 Foundation GCSE Maths Paper 1, which is the non-calculate paper. So, I'm going to put links down below in the description to paper 2 and 3, as well as some other useful bits and bobs to help with your revision. So make sure you check that out, give us a thumbs up, get subscribed, and let's do this. Question 1 wants us to write 6,324 correct to the nearest thousand. So we got 6,324. So given that we got a 3 after the 6, the nearest thousand is 6,000. Question 2 wants us to write these numbers in order of size, starting with the smallest. So the smallest number here is minus 6, and then minus 5, and then 0, and 6, and then 12. Part B, same job again, but we got some decimals. So these decimals have a different number of decimal places. So a nice little cheat with these is to make it so they all have the same number of decimal places. So what do I mean by that? 0.078 has 3 decimal places. 0.78 only has 2. We can make it 3 though by putting a 0 on the end like that. And then the same with 0.870, like that. Okay, so our smallest number here is 0.078. It has a 0 in the tens column. It's the only one that does that, so that's our guy. Okay. Next, we've got 2 numbers that have a 7 in the tenths column. So we got 0.780 or 0.708. So the next smallest number is 0.708 because that has a 0 in the hundredths column. And then it's 0.78, and then it's 0.87. Cool. Question 3 wants us to write 20% as a fraction. So, percent means per 100. So 20% means 20 over 100. Now it doesn't ask for it in its simplest form, so that is fine. However, we can simplify it. There's a common factor, first of all, between the top and bottom of 10. So if we divide the top and bottom by 10, we get 2 over 10. And then we've still got a common factor of 2. So if we divide the top and bottom by 2, we get 1/5. Cool. Question 4. So we got a list of 4 fractions. We are told one of the fractions is not equivalent to 1/4. We want to write down which one. So, 4/16 has a common factor of 4. So if we divide the top and bottom by 4, we do get 1/4. 2/8 has a common factor of 2. So that does simplify down to 1/4. 15/60 has a common factor of 5. So 15 divided by 5 is 3. 60 divided by 5 is 12. 3/12 still has a common factor of 3. So that does simplify to 1/4. 3/9 has a common factor of 3. 3 divided by 3 is 1. 9 divided by 3 is 3. So 1/3 is not 1/4. So our answer is 3/9. Cool. Question 5. Write down the first even multiple of 7. So multiples of 7 are just the 7 times table. So we want the first even number in the 7 times table. So we got 7, no, 14, bingo. So it's 14. Cool. 6a wants us to simplify 3 times 4t. 3 times 4 is 12. So 3 times 4t is 12t. And then 6b wants us to simplify 8a minus 3a add 2a. So think of this as apples. If we've got 8 apples and we take away 3 apples, that's going to leave us with 5 apples. And then we're adding 2 apples. So altogether we've got 7 apples. Question 7. Here is a probability scale. It shows the probability of events A, B, C and D. Part A wants us to write down the letter of the event that is certain. So if the event is certain, it has a probability of 1. So that is D. On the flip side, if an event is impossible, it has a probability of 0. So here we can say event A is impossible. B wants us to write down the letter of the event that is unlikely. So slap bang in the middle, we have a probability of 1/2. If an event has a probability of 1/2, it's as likely to happen as not happen. If it's on the left but not impossible, then it's unlikely. If it's on the right but not 1, then it's likely. So the unlikely event is B. So event C would be likely. Okay, then we're told there are 12 counters in a bag. 3 of them are red, 1 of them is blue, 2 of them are yellow, and the rest of them are green. K then takes a random counter from the bag. We want to show the probability that the counter is yellow or green is 2/3. So we need to know how many counters are green. So if we add up all the other counters, 3, add 1, add 2 is 6. So that means then we got 12 minus 6, which is 6. That's how many green counters we've got. So, we want the probability of getting green or yellow. So, altogether, green and yellow counters is 6 add 2, which is 8. So the probability of green or yellow, the chance that we get a green or a yellow counter is 8 out of 12, which has a common factor of 4, so it's 2/3 as we wanted. Okay, question 8. 3 kilograms of meat costs £54. And Nina buys 2 kilograms of the meat. We want to work out how much Nina pays. So, if 3 kilograms costs £54, and then 1 kilogram is going to cost a third of that. So, £54 divided by 3. So let's use the bus stop to do that. 54 divided by 3. 3 goes into 5 once, with a remainder of 2. And then 3 goes into 24 8 times. So 54 divided by 3 is 18. So 1 kilogram of the meat costs 18 pounds. So 2 kilograms is going to cost 2 times 18 pounds, which is 36 pounds. Question 9. So here we got a circle. The cross is the centre of the circle, and we are asked to write down the name of the straight line in the circle. So a line from the centre to the circumference is called a radius. Okay, then in part B, we got a straight line touching the circle only once. This guy is called a tangent. Question 10. Tim and 3 friends go on holiday for a week. The 4 friends will share the costs of the holiday equally between them. Here are the costs of the holiday. So £1,280 for 4 return plane tickets, £640 for the villa, and £220 for the hire of a car for the week. We want to work out how much Tim has to pay for his share. So we need to work out the total cost and then divide that by 4. So we're going to do 1,280 add 640. Now if you like, we could just add those together first of all, and then add on the third thing to that. So let's do that. So starting from the right, 0 and 0 is 0, 8 and 4 is 12, so we stick 2 there, carry the 1, 2 add 6 is 8, add 1 is 9, and then the 1 just falls down. So at the moment we got 1,920. So now we need to add on the cost of the car. So now we're going to do 1,920 add £220. Okay, so again starting from the right, 0 add 0 is 0, 2 add 2 is 4, 9 add 2 is 11, stick a 1 there, carry 1, 1 add 1 is 2. So the total cost of the holiday is £2,140. So total is 2,140. So to work out Tim's share, we need to divide this by 4. So Tim's share is 2,140 divided by 4. And let's use the bus stop. Okay, so starting from the left, 4 does not go into 2, put a 0 up there, carry the 2 onto the 1, 4 into 21 goes 5 times, with a remainder of a 1, 4 into 14 goes 3 times, which is 12, so there's a remainder of 2. 4 into 20 goes 5 times. So Tim's share is £535. Okay, question 11, we want to write down examples for each of these statements to show that they are not correct. So statement A, the factors of an even number are always even. Can we think of any of those that are not true? The simplest, I guess, would be 1 is a factor of 2. 1 is odd, so it's not true. Okay, and then B, all the digits in an odd number are odd. So let's say 21 is an odd number, but 2 is even. Okay, question 12. A shop sells desktops, laptops and tablets. The composite bar chart shows information about the sales over 3 years. So looking at the key, black is desktops, white with black lines is laptops, and grey is tablets. So the years we've got 2015, 2016 and 2017, and at the side we got the number sold. So part A wants us to write down the number of desktops sold in 2015. So desktops are the black. Hopefully we can see quite easily. That is going to be 100. Part B wants us to work out the total number of laptops sold over the 3 years. Okay, so in 2015, here, our top mark is 260, and our bottom mark is 100. So altogether here, in 2015, they sold 160. In year 2, the bottom of laptops is going to be 120. And then the top is going to be 340. So the number sold in 2016 is 340 minus 120, which is 220. And then in 2017, our bottom mark is going to be 160. And our top mark is going to be 440. So the number sold in 2017 is 440 minus 160, which is 280. So our total laptop sold is 160 and 220 and 280. Okay, so 220 and 280 is 500. So 160 at 500 is 660. Part C asks us to state the item that had the greatest increase in sales over the 3 years and give a reason for our answer. So hopefully it's quite easy to see that it's tablets. So it's going to be tablets. And just by looking at it, we can sort of say with sales at least doubled each year. So we could say the sales seem to roughly double each year. Cool. Okay, then for part D, Alex says, in 2017, more tablets were sold than desktop computers. This means the shop makes more profit from tablets than from desktop computers. Is Alex correct? Give a reason for your answer. So, what we should really say here is that we can't tell if he's correct. But the reason is, so I guess we could just say no. The reason is, we don't know anything about the profit that they make from sales of tablets and desktops. They might only make £1 profit from selling a tablet, and they might make £100 profit by selling a desktop. So the answer we would put then is no. We don't know. About the profit from sales of tablets and desktops. Cool. Question 13. A piece of wire is 240 centimeters long. Peter cuts two 45 centimeter lengths of wire off of the wire. He then cuts the rest of the wire into as many 40 centimeter lengths as he can. We want to work out how many 40cm lengths Peter will have at the end. So, first of all, let's work out how much wire the two 45cm lengths take. So, 2 times 45 centimeters is 90 centimeters. So we need to work out how much wire he has left after cutting these two pieces off. So 240 minus 90 it's going to give us 0 take 0, we can't do, yes we can, 0 take 0 is 0, we can do that, 4 take 9 we can't do, so borrow 1 from the 2, 14 take 9 is 5, and then the 1 just falls down. So the piece of wire he has left is 150 centimeters long. Okay, so we can definitely cut off one 40cm length, so we can even cut off another one. That would take us up to 80 centimeters. We could even go another one along. So 80 plus 40 is 120 centimeters. So up to there, he's got 1, 2, 3 40cm lengths. Now remember, the whole length of the wire that he's using now is 150. So what's left here is only 30 centimeters. So he's only going to have enough for 3 40cm pieces of wire. Question 14. Gavin, Harry and Isabel each earn the same monthly salary. Each month, Gavin saves 28% of his salary and spends the rest. Harry spends 3/4 of his salary and saves the rest. The amount of salary Isabel saves to the amount of salary she spends is 3 to 7. We want to work out who saves the most of their salary. We must show how we get our answer. So what we need to do for each of these, we need to work out what proportion they each save, and in the same form, so all in a ratio or a percentage or a fraction, etc. So what I'm going to go for here is percentages. So Gavin saves 28%. So awesome, you got that straight away. Harry spends 3/4, so he saves 1/4. So Harry saves 1/4, which is, as a percentage, 25%. Okay, now Isabel is a bit awkward because we are in a ratio. So for Isabel, she saves to spend 3 to 7. So what she is doing is splitting her total salary into 10 parts. So let's say her total salary is in 10 parts. So where that 10 comes from is 3 add 7. Now she saves 3 parts out of the total 10 parts. So that's the fraction of her salary she saves. 3/10 is 30%. So Isabel saves the most. Isabel is our answer. Question 15 wants us to work out 15% of 160 grams. So 10% would be 16 grams. 5% is half of 10%. So half of 16 is 8 grams. Add those together, 15% is 24 grams. Cool. Okay, 16a. P is 4x at 3y. X is equal to 5. Y is equal to minus 2. Work out the value of P. So we substitute the values in, we get P is 4 times 5, add 3 times minus 2. 4 times 5 is 20. 3 times minus 2 is minus 6. So we're adding minus 6. So we're minusing 6. So that gives us 14. Part B wants us to expand 4e times e plus 2. So expand means multiply out. So the 4e on the outside multiplies both things on the inside of the brackets. So I'm going to do this using a table because it lays it out nicely. So we're going to put 4e here and then e and 2 on top. Now 4e times e is going to be 4e squared, and then 4e times 2 is 8e. So our answer is 4e squared add 8e. Part C wants us to solve 3 lots of m minus 4 is equal to 21. So I'm going to do this 2 ways, just to show you that we can. So the first way, we're going to expand the brackets, so we get 3m minus 12 is equal to 21. Okay, we want to add the 12. So that's going to give us 3m is equal to 33. And then that 3 is multiplying the m, so to get rid of it, we divide both sides by 3. And we get m is 11. Now we could have done this without expanding the brackets. So when we've got 3 lots of m minus 4 is equal to 21. So instead of expanding the brackets, we could have divided through by 3 from the start. So that would then leave us with m minus 4 is equal to 7, and then we want to add 4, and we get m is 11 again. So either one of those methods is absolutely fine. Cool. Okay, question 17. There are some chocolates in a box. Good times. 1/4 of the chocolates contain nuts. The rest of the chocolates do not contain nuts. We want to write down the ratio of the number of chocolates that contain nuts to the number of chocolates that do not contain nuts. And we want to write our ratio in the form 1 to n. So, first of all, if 1/4 contain nuts, and then what fraction do not contain nuts? 3/4. Okay, so as a ratio, I'm going to do it as nuts to no nuts. It's 1/4 to 3/4. Now that is the ratio, but it's not in the form that they want it. They want 1 to n. Now fortunately, both sides of this ratio have a 4 on the bottom of the fraction. So what we're going to do is multiply both parts of the ratio by 4, and we get 1, 2, 3. Okay, question 18. So we got some set notation here. So A is our set of numbers that are multiples of 5 between 14 and 26. So that's 15, 20, 25. B is our set of numbers that are odd between 14 and 26. So we got 15, 17, 19, 21, 23, 25. Part A asks us to list the members of A union B. Now in English, A union B means A or B. So, in terms of our sets, we want numbers that are either a multiple of 5 or odd. So, between 14 and 26, we've got 15, we've got 17, we've got 19, we've got 20. Because 20 is a multiple of 5. Then we got 21, 23, and 25. Cool. Okay, then part B says to describe the members of A intersection B. So again, in English, A intersection B means A and B. So when it says describe the members of A intersection B, it doesn't mean to list the numbers. It means to describe what this set means. So it means A, which is a multiple of 5, and B. So and odd. between 14 and 26. Okay, next up, we want to work out 2 and 1/7 add 1 and 1/4. So, mixed numbers. I might actually show you 2 ways to do this as well. There is a little cheat. We'll do it the proper way first of all. So, to add mixed numbers, we first of all need to turn them into improper fractions. So, for 2 and 1/7, we do 7 times 2, add 1 up on top, all over the bottom of the fraction, and then for 1 and 1/4, we do 4 times 1, add 1 all over 4. So 7 times 2, add 1 is 15. So we got 15/7, add 4 times 1, add 1 is 5. So we got 5/4. Okay. Now, to add fractions, they need to have common denominators. So now we need to think, what is the smallest number 7 and 4 both go into, which is 28. So we're going to multiply 15 over 7 by 4 on the top and on the bottom. 4 times 15 is 60. 4 times 7 is 28. And then to turn 4 into 28, we need to multiply by 7. So we do that to the top as well. So that gives us 35/28. Now we have the same number on the bottom. We just add the tops. And we get 95/28. So that's one way. And that would be fine. Really, that would be what you want to do. But we could speed it up a little bit. Think of a mixed number as telling us how many whole pizzas we've eaten, and add a fraction of a pizza that we've eaten. So 2 and 1/7 means 2 add 1/7. And then 1 and 1/4 means 1 add 1/4. So, here then we've got 2 add 1, that's our whole pizzas, add 1/7, add 1/4. So 2 add 1 is 3. And then we need to add the fractions. So again we're going for 28. So 1/7 is 4/28. And 1/4 is 7/28. So if we add those together, we've got 3 add 11/28. So as a mixed number, our answer is 3 and 11/28, which is exactly the same as the improper fraction we just worked out. They're just in slightly different forms. So it's a nice little cheat. It does work. If you want to use it, make sure you practice it. Okay, then part B wants us to work out 1 and 1/5 divided by 3/4, giving our answer as a mixed number in its simplest terms. So, first of all, we have a mixed number here, so we need to turn that into an improper fraction. So 1 and 1/5 is 6/5 divided by 3/4. Now to divide by a fraction, you flip him over and multiply by it. So we get 6/5 times 4/3. Now to multiply fractions together, it's the nice one. We do the top times the top over the bottom times the bottom. So 6 times 4 is 24. 5 times 3 is 15. That then has a common factor of 3. So it's 8/5. So that is the answer as an improper fraction. We want it as a mixed number. So we can think of this as 5/5 add 3/5, which is 1 and 3/5. Good times. Okay, then question 20. So by the way, we are now in the questions that are also on the higher paper. So we got a lovely ratio one here. In a village, the number of houses to the number of flats are in the ratio 7/4. So I'm going to write that down. H to F 7/4. And the number of flats to the number of bungalows are in the ratio 8/5. So flats to bungalows are 8/5. We're told there are 50 bungalows in the village. We want to work out how many houses there are. So I'm going to do this by combining these two ratios. Now I've got a video on that. I'll put that down below in the description. So the key to combining ratios is the part of each ratio that pops up in both of them. So here, both ratios contain flats. So what we need is to make that part of each ratio the same number. Now we can do that quite easily here by multiplying the houses and flats ratio by 2. So if there are 7 houses for every 4 flats, we know there are 14 houses for every 8 flats. So now we know for every 8 flats there are 14 houses and 5 bungalows. So as a single ratio, H to F to B, we've got 14 to 8 to 5. Now, we know that there are 50 bungalows in the village. How do we get from 5 to 50? We multiply by 10. So, we multiply both of the other parts of the ratio by 10. So, we can actually say there are 80 flats. More importantly though, there are 140 houses. So 140 is our answer. Cool. Okay, 21, we got a pretty big arithmetic question here. So Renee buys 5 kilograms of sweets to sell. She pays £10 for the sweets. Renee puts the sweets into bags. Each bag is 250 grams. She sells each bag for 65p. She sells all the bags. We want to work out her percentage profit. To be able to do that, we're going to need to work out the profit that she makes. Profit is the amount of money that you make after you've made back what you had to spend. So we know here that sweets cost her £10. So what we need to work out is how much money she made by selling the sweets. To do that, we need to know how many bags of sweets she sold. So, she puts the bags then she puts 250 grams into each bag. So, 1 kilogram is 1,000 grams. So, 1 kilogram is 4 times 250 grams. So, 1 kilogram is 4 bags of sweets. So, 5 kilograms is 5 lots of 4 bags, which is 20 bags. Okay, so she has 20 bags of sweets to sell. She sells each bag for 65p. So now we need to work out 20 times 65p. Now I'm actually going to do that in terms of pounds. So 65p in terms of pounds is 0.65. Now, to do this, that probably does something very nice. We can first of all do 10 times 0.65 pounds, which is £6.50. And then we can do 2 times £6.50. 2 times 6 is 12. 2 times 50p is £1. So that's £13. So she makes £13. Now her profit is £13 minus £10, which is £3. So £3 is her profit. We want percentage profit. So percentage profit is the profit divided by the amount she spent. So profit divided by spend times 100. So profit was £3, she spent £10. So this is 3/10 times 100, which gives us 30%. Okay, question 22. So a cycle race across America is 3,069.25 miles in length. One knows that his average speed for his previous races is 15.12 miles per hour. For the race across America, he's going to cycle 8 hours per day. We want to estimate, keyword, estimate the number of days it will take one to complete the race. So this is a non-calculator paper. We're told to estimate. We need to make the numbers nicer. So the total distance, 3,069.25 miles. We're gonna round that to 3,000 miles. His speed, 15.12 miles per hour. We're going to round to 15 miles per hour. Okay, so now that we've rounded, the numbers are looking nicer. Now the question is asking us to estimate how many days it's going to take him to complete the race. We know each day he's going to cycle for 8 hours. So what we can first of all work out is how far he's going to get per day. So the distance per day, well, if we're saying he's going at 15 miles per hour and he's travelling for 8 hours a day, he is going to get 8 times 15 miles per day. Now, 8 times 10 is 80, 8 times 5 is 40. So, adding those together, he is going to go 120 miles per day. So we now want to work out how many days it's going to take him to complete the race. So now we do the total distance, 3,000 miles divided by 120 miles. So I've decided to write this as a fraction because I think it's the easiest form. So let's see what common factors we can cancel out. First of all, both numbers end in a 0. So there's a common factor of 10. So we can cancel that out. So this is 300 over 12. Both numbers are even. So 300 divided by 2 is 150. 12 divided by 2 is 6. Both numbers then are still even, but 150, maybe not that nice. Both numbers have a common factor of 3. So this is 50 over 2, which is 25. So our estimate is 25 days. Okay, then for part B, one trains for the race. The average speed he can now cycle increases. It is now 16.27 miles per hour. How does this affect your answer to part A? Well, if one goes faster then the race will take him less time. So that could be one answer, although it does say how would this affect our answer to part A. So there is also an argument here that we could say, well, we might still round 16 point whatever down to 15. So if we did that, it wouldn't affect our answer at all. So either one of those, we would be fine. Okay, question 23. So we got a solid square-based pyramid V, A, B, C, D. So the base is a square of side length 6 centimeters. The height of the pyramid is 4 centimeters. And we've also got this point M, which is the midpoint of BC, and the length VM is 5 centimeters. So that means the length from the tip of the pyramid going diagonally down to the middle of the base, or the edge of the base, is 5 centimeters. Part A wants us to draw an accurate front elevation of this pyramid. So, if we were looking at this pyramid, the base is 6 centimeters long and the height is 4 centimeters. And we know that V, the tip, is going to be exactly in the middle. So what we're going to get is something that looks like this chap. Base of 6, height of 4, with the top directly in the middle. Cool. Then part B wants us to work out the total surface area of the pyramid. So the surface area means the area of every single face. So first of all, we know the base is a square with side lengths of 6 centimeters. So the area of the base is 6 times 6, which is 36 centimeters squared. Okay, now we need to think about one of the triangles. So we know the base of the triangles. You can see my drawing is as good as ever. We know the base of the triangles is 6. What about the height? Well, now we are looking at this 5 centimeter length that goes up from the middle of the triangle to the tip. So the height of these triangles is 5. Now, the area of a triangle is the base times the height divided by 2. So here we're doing 6 times 5 divided by 2, which is 30. Thank you, Mr. Postman. Which is 30 divided by 2, which is 15 centimeters squared. Now there are 4 triangles, so the surface area is the area of the square, 36 centimeters squared, add 4 lots of the triangle, 4 times 15 centimeters squared. 4 times 15 is 60. So we got 36 and 60, which gives us 96 centimeters squared. Good times. Okay, question 24. Now I'm really surprised to see this on the foundation paper. I know from the reactions last year, this was one of the questions just nobody could do. So, a pattern is made using 4 identical squares. The sides of the squares are parallel to each other. Sorry, parallel to the axes. So we got these 2 points. We got point A down here, which has coordinates 6, 7, and then we got this point up here, point B, with coordinates 38, 36. Now we've also got this point here, C, and that is our mission to find the values of, find the coordinates of point C. So it is a tricky question, to be fair. We need to first of all ask ourselves, what do we know about squares? Their side lengths are the same, so the base is the same as the height. Now, we don't know, starting off, what the base and the height are, so I'm going to call the length M. Okay, now let's think about this. Can we work out the value of M? Well, we know going from left to right, we are going along 4 base lengths of the squares. So we are going from 6, we're going along by M, along by M again, along by M again, along by M again, and now our x coordinate is 38. So we know then, we can get that equation here. We know that 6 add 4 base lengths, so 4m is equal to 38. Now if we take 6 away, we get 4m is 32, and then divide by 4m is equal to 8. So now we know the side lengths of the square. So, looking at point C, we can see the x coordinate of C is going to be 2 of the squares to the right of point A. So we're going from 6, we're going across by 8, and then we are going across by another 8. So the x coordinate of C is 6 add 8 add 8. 6 add 16 is 22. So our x coordinate is 22. Now, point C is sort of along the height of this second square. So we can't go up from point A, but it is at the bottom of this square. It's at the bottom left. So how are we getting down from the y coordinate of B to the y coordinate of C? Well, we are going down by 8 and then down by 8 again. So the y coordinate of C is 36 minus 8 minus 8. So 36 minus 16 gives us 20. So the coordinates are 22, 20. Tricky. 25 wants us to draw the graph of y equals 1 minus 4x for values of x from minus 3 to 3. So to draw a straight line, you need 3 points. Why 3 and not 2? If you only do 2, there's no indicator as to whether you've cocked up. If you do 3 and all 3 points lie on the line, it's a nice sign that you should be right. So we're going to use a coordinate table, and I'm going to use values of x of 0, 1 and 2. So y, remember, is 1 minus 4x. So when x is 0, y is 1 minus 4 lots of 0, which is 1. When x is 1, y is 1 minus 4, which is minus 3. And when x is 2, y is 1 minus 2. No, it's not. It's 1 minus 8, which is minus 7. So if we plot those 3 points, our point should look like this, and then just join them up with a straight line. Just be a little bit careful. They've used different scales on the x and y axis. On the y axis, every square is 1 unit. On the x axis though, 2 squares is 1 unit, which is really annoying, kids. But our graph should look like that. Okay, final question. So we want to, we got 2 vectors. A is 5, 2, and B is minus 1, 7. We want to work out 2A and B as a column vector. So I'll put my column vectors video down below. 2A literally means 2 times the vector 5, 2. And we just multiply the numbers by 2. So it's 10, 4. So 2A and B is 10, 4 add minus 1, 7. So when you add vectors, you add the corresponding parts. So we got 10 add minus 1 is 9, and then 4 add 7 is 11. So there it is. Okay guys, that's this paper done. Really hope you found it useful. Don't forget, give us a thumbs up, get subscribed, drop a comment down below, let me know how you found this paper. Good luck for your exams. See you in papers 2 and 3.